Welcome back to the channel, and today we are going to discuss one of the very important topic of unit 1 of CBSE 11th physics, that is error and its type. After error and its type we will have another video for the propagation of errors, but in this particular video we are going to cover about what errors are and how many types of error exist. So without any delay, let's start with the video. Okay, so let's talk about the errors first, that what errors are. We will discuss about its type also, and we will discuss about what errors are. So कभी भी हम कोई ऑब्जर्वेशन करते हैं, कभी भी हम कोई एक्सपेरिमेंट करते हैं, हम कुछ वैल्यूज को मेजर करते हैं. जो भी वैल्यू हम मेजर कर रहे हैं, जो भी पैरामीटर हम मेजर कर रहे हैं, उसकी कुछ ना कुछ वैल्यू पहले से ही एक्सपेरिमेंटली वेरीफाइड होती है, साइंटिफिकली वेरीफाइड होती है, जिसके नियर अबाउट हमें क्या करना होता है, अपनी एक्सपेरिमेंट्स को परफॉर्म करके उनकी वैल्यू को इवैल्यूएट करना होता है. जैसे कि एक एग्जांपल हम कंसीडर अगर करते हैं कि अगर हम एक्सेलरेशन ड्यू टू ग्रेविटी को इवैल्यूएट कर रहे हैं, तो एक्सेलरेशन ड्यू टू ग्रेविटी की वैल्यू कितनी होती, दैट इज g इज इक्वल्स टू 9.81 मीटर per second square. This is what the value of acceleration due to gravity is. Okay, now when we are performing the experiment, we will try to find out various values of g, and suppose the value whatever we are computing, जितनी भी values हम लोगों ने निकाली हैं, जो भी compute की है, उनका अगर mean compute करते हैं, तो हमारी g की value क्या आई, हमारी g की value आती है 9.70 मीटर पर सेकेंड स्क्वायर. ओके, ये हमारी वैल्यू है. तो ये वैल्यू कौन सी थी, ये वैल्यू जो ऊपर लिखी हुई ये कौन सी थी, ये एक्सपेरिमेंटल वैल्यू थी, जो कि पहले से ही स्टैंडर्डाइज करके रखी गई है. ठीक है, ये वैल्यू स्टैंडर्ड वैल्यू है, या इसी को हम एक और नाम से जानते हैं, यहाँ फिजिक्स में हम इसे बोलते हैं, वी कॉल इट एज ट्रू वैल्यू. ठीक है, इसे हम क्या कहते हैं, वी कॉल इट एज ट्रू वैल्यू. हम इसे ट्रू वैल्यू कहते हैं क्योंकि ये ऑलरेडी स्पेसिफाइड वैल्यू है, और ये एक ऐसी वैल्यू है जो कि पहले से ही हमें पता होती है कि हमें इसी के अबाउट, नियर अबाउट वैल्यू को कैलकुलेट करना है. अब ये जो वैल्यू है, ये 9.70, ये कौन सी है, ये हमारी मेजर्ड वैल्यू है. दिस इज अवर मेजर्ड वैल्यू, ये हमारी मेजर्ड वैल्यू है. इसे हमने मेजरमेंट के थ्रू, एक्सपेरिमेंट्स के थ्रू क्या किया है, मेजर किया. सो एक हमारी हो गई ट्रू वैल्यू और एक हमारी हो गई मेजर्ड वैल्यू. अब अगर हमें एरर निकालना है, तो ये वैल्यू प्रिसाइज तो आई नहीं, हमें कंप्यूट कितनी करनी थी, हमें कैलकुलेट करके वैल्यू जो निकालनी थी वो निकालनी थी 9.81, बट हमने कैलकुलेट कितनी की है, हमारी कैलकुलेशंस के अकॉर्डिंग वैल्यू आ रही 9.70, विच इज नियर अबाउट द ट्रू वैल्यू बट नॉट एग्जैक्टली द ट्रू वैल्यू. सो मेजरमेंट क्या है, मेजरमेंट इसी क्लोजनेस को, इसी प्रिसाइजनेस तक जाने मेजर करना था, इतना लाना इतना था, लेकिन आई हमारी वैल्यू इतनी है, जो कि नियर अबाउट तो है बट प्रिसाइज नहीं है. कितनी वैल्यू से प्रिसाइज नहीं है, कितनी मार्जिन से हम पीछे रह गए अपनी इस एग्जैक्ट वैल्यू को अटेन करने से. तो अगर ये कंप्यूट करना हो तो कैसे करेंगे, आपसे अगर मैं यही क्वेश्चन अराइज करूंगा तो आप सिंपली क्या करेंगे, आप 9.81 से माइनस कर देंगे 9.70 को, और उसके बाद आप कहेंगे कि 0.11 मीटर पर सेकेंड स्क्वायर, इस मार्जिन से हम पीछे रह गए. यानी कि हमारी जो वैल्यू आई है उसमें अगर इतना और होता तो हमारी वैल्यू एग्जैक्टली परफेक्ट होती, जो कि एक ट्रू वैल्यू है. तो यानी कि क्या है, इतना हमारा जो है क्या है, दिस इज व्हाट, दिस इज अवर एरर. ये हमारा क्या है, एरर है. इतना एरर रह गया, इतना पीछे रह गए, इतना हम अटेन नहीं कर पाए, इतनी वैल्यू को और अटेन करना चाहिए. तो ये क्या है, दिस इज द एरर. ओके, सो हमने इसे कैसे कंप्यूट किया है, हमने इसे कंप्यूट किया है 9.81 से सब्ट्रैक्ट करके 9.70 को. 9.81 आपका क्या था, इट वाज ट्रू वैल्यू, इसे लिख देते हैं यहाँ पर, इट वाज व्हाट, इट वाज ट्रू वैल्यू, और हमने उसमें से क्या किया, सब्ट्रैक्ट किया है किसे, मेजर्ड वैल्यू को. ठीक है, हमने उसमें से मेजर्ड वैल्यू को सब्ट्रैक्ट किया हुआ है. तो इससे हमें क्या मिला था, एरर मिला था. ये हमारा क्या हो जाएगा, ये हो जाएगा हमारा एरर. सो एरर क्या होता है, एरर हमारा है ट्रू वैल्यू को, ट्रू वैल्यू से जब हम सब्ट्रैक्ट करते हैं मेजर्ड वैल्यू को, तो हमें क्या मिलता है, एरर मिलता है. मींस इट इज द डिफरेंस बिटवीन ट्रू वैल्यू एंड मेजर्ड वैल्यू. कितना हम डेविएट हुए हैं ट्रू वैल्यू से, अगर क्वालिटेटिवली मैं बात करूं तो हम ट्रू वैल्यू से कितना डेविएट हुए हैं, वो हमारा कहलाता है एरर. और मोस्टली एक्सपेरिमेंट्स जितने भी हैं, मोस्टली मेजरमेंट्स जितने भी हैं, कहीं ना कहीं कुछ ना कुछ, maybe even a 0.001%, but yes, there are some errors there. कुछ ना कुछ एरर्स तो हमेशा रहते हैं, कई फैक्टर्स की वजह से होते हैं, एंड डिपेंडिंग अपॉन दीज फैक्टर्स, डिपेंडिंग अपॉन दीज various reasons, we have classified errors into the various categories. What are those categories? What are the types of error? Now we are going to discuss about that only. So I hope this is clear. This is quite clear that what errors are and how error is computed. Okay. Now let's start with the types of error. So if I talk about types of error, basically types of error are of three types. They are broadly classified into three categories. What are the three categories? See, first it is constant error. First it is constant errors. Okay. Next, second category is systematic error. It is systematic error. And last but not the least, these are random errors. Random errors. So we are going to talk about these errors one by one. I hope you people are writing it also. So let's first talk about the constant error. Now what constant errors are? Constant errors are basically those errors which are creeping because of the continuous n number of observations which we are taking in an experiment, and every time you are taking some sort of reading, some sort of observation, the error margin remains constant. Means, if suppose let's take the same example of computing the value of g. So original value, that is true value, is 9.81 meter per second square. But suppose if somebody is performing the experiment to compute it, and let's say in first reading it computed the value of g as 9.70 meter per second square. So the error margin is how much? It is 0.11. Again in the second reading or in the second observation, the value remains same, 9.70 meter per second square. Again the error is 0.11. In the third time also we will have 9.70 meter per second square. Means again the error is same. Means you can see, doesn't matter how many readings we are taking, 1, 2, 3, every time whenever we are having the reading, the error margin remains constant. The error margin remains constant, and hence such kind of errors are termed as constant errors. Okay, such kind of errors are termed as constant when we are having n number of back-to-back repeated readings, and in every reading we are having the margin of error from the true value, that is the deviation from the true value, it remains constant. That is why these are named as the constant error. Okay, we are not talking about systematic error right now. First we will talk about the random errors, then we will go for the systematic errors. What are random errors? The word random itself says the story. Yes or no? The word random itself says the story. Random errors are basically the errors which will always be there. Don't know what will be the reason for them, but yes, they will persist. They will always persist there. The reason of such errors is quite unknown. Suppose if one person is performing the experiment and he is getting some sort of value, and another person is performing the same experiment with the same apparatus, with the same arrangement, and he can observe different values. So error will always be there, but the reasons will be unknown. That then find करना थोड़ा सा मुश्किल होता है. क्यों? क्योंकि जैसे मान लीजिए कोई एक स्ट्रेंदी पर्सन है, जिसके स्ट्रॉन्ग पर्सन है, ताकतवर पर्सन है, तो वो उसने क्या किया, उसी एक्सपेरिमेंट को कर रहा है, कोई स्क्रू को टाइट करना है तो उसने उसको बहुत ही स्ट्रांगली टाइट किया. और एक कोई पर्सन है जिसने उसको उतनी स्ट्रेंथ नहीं लगाई, थोड़ा लूज स्क्रू टाइट किया, तो उससे वैल्यू कम मिल सकती है. या सपोज एक वायर है, ठीक है, अगर वो वायर कहीं से थोड़ा सा उसकी थिकनेस कम है और कहीं पे थोड़ी थिकनेस ज़्यादा है, तो किसी ने उसको ज़्यादा थिकनेस वाले एंड से उसका रेडियस मेजर किया और किसी ने कम थिकनेस वाले से किया, तो सेम अपैरेटस है, सेम प्रोसेस है, सेम लेबोरेटरी, लेकिन एरर्स क्रीप कर रहे हैं. तो ये कैसे एरर होते हैं? इस तरीके के जितने भी एरर्स हैं, दे आर क्लासिफाइड एज रैंडम एरर्स. सो बिकॉज दे आर रैंडम इन नेचर, we cannot figure it out ki what are the reasons, but if we come to know about the reasons, we try to rectify them. If the reasons are unknown, we accept those errors in our measurement. So random errors are like that only. Now coming up to the most important part of types of error, that is systematic error. Now systematic errors may be because of the various factors. There are various factors for the systematic error, and depending upon those factors, these systematic errors are also classified. They are further classified. How and in what categories? Let's talk about them one by one. Okay, so let's talk about one by one. Let's talk about them one by one. First is your instrumental error. Now instrumental error is basically because of the fault in the instrument. You might using some sort of instrument to measure the error, but if the instrument is faulty, how can you measure that particular value? You cannot measure. Suppose if we have to measure the road, and if I give you a scale of 15 centimeter, obviously there will be error. If I give you a scale with broken edges and I tell you to draw a line, I instruct you to draw a line of 5 centimeter or maybe 6 centimeter, but if the edges are broken, you cannot have the precise measurement. So this is why this is happening, because the instrument, the tool which is provided, it is not up to the mark and it is causing certain sort of errors. So the errors which are creeping because of the lack of efficiency of the instrument, preciseness of the instrument, absoluteness of the instrument, that is known as instrumental error. Second one, that is personal error and observational error. Now what are these? These errors are the errors which creep because of the observer or the performer, the person who is performing the experiment. Suppose the common example for such kind of error is parallax. A common example of such kind of error is parallax. Now what is parallax? See, if we have a tube with some readings, or you can say some margins like this, you might have seen it in the chemistry lab or in the physics lab. If this is the tube, okay, and suppose water is filled in it with a level of up to 15 centimeter, okay, 15 centimeters is the height up to which the water is filled. Now if we have to make the reading precise, how we have to see? We have to keep our eye here itself only, na? So that line of sight could be maintained. What should be maintained? Line of sight could be maintained. But suppose if we are watching it from top, if eye is here, or from bottom, let's say eye is here, so what we will get? Either we will get a little bit more value or we will get a little bit less value, which will always cause error, yes or no? Means we are not watching it from the line of sight, we are watching it above or below from the line of sight. So it is where the error creeps, and such kind of errors, because of the perception of viewing it, these errors are known as parallax. Generally these errors arise in optical experiments, optical instrument experiments. Likewise we are having mirror formula experiment and lens formula experiment. There you will see that the edges like this, this will be the object, this will be the image, and if you see from the front end, you will see it like this only, okay. But if you move your neck like this, you will find that the image is not coinciding over the tip of the object, it is slightly deviating from the path. So such kind of errors are known as parallax error, and these needs to be removed in order to have the precise measurement, okay. Third one is your error due to imperfections. Now what are these errors? These errors are because of the imperfection in nature of the observer. Maybe observer is quite careless, maybe he is not taking proper care of the instrument, maybe he don't know about the exact procedure of considering the experiment. So in such cases always there will be a chance of error, and such errors which are creeping because of the carelessness attitude of the person, because of the various reasons which person is not capable enough to handle the experiment, such errors are known as errors due to imperfections, okay. Last but not the least is the errors due to environment. Suppose if there is a experiment which we have to perform, in which we need to keep a moderate temperature. Moderate temperature means a room temperature generally, but if the laboratory is equipped with AC and you are keeping the temperature 16 or maybe less than that, so you are disturbing the room temperature, na? Means it will be a slightly cooler atmosphere there, okay. So it will not be precise for the experiment. Why? Because room temperature was needed and you have lowered the temperature, so that lowering of the temperature will affect the readings, will affect the experiment, and such kind of errors which will creep because of the lowering of the temperature, because of tempering the temperature, that will be fall under the category of errors due to the environment. Means you are tempering the environment. It could be because of any factor like heat, temperature, wind is there. If we are performing an experiment in which a moderate wind or a gentle breeze is needed, but somehow you are performing experiment in an open environment and there is lot of wind going there, okay. So in that case what will happen? It will be error. So such kind of errors are arising because of the environmental issues, because of the environment which we are creating in the laboratory or from wherever we are performing the experiment. So such kind of errors will fall under this particular category. Okay, so these are basically the types of error. Apart from these, we are having 3 more types of error which are not categorized under this, but they are under the quantitative analysis. So on quantitative analysis, we have another class of errors. I hope these errors are clear to you. And now we are going to quantitative approach. These were the qualitative approach. Now we are going to quantitative approach of the errors. On the basis of quantitative approach, we are having 3 types of error. What are those? We are having 3 types of error. Number 1 is absolute error. Second one is your relative error. And third one is your percentage error. Okay, these are the 3 errors which are based on the quantitative approach. Okay, on quantitative approach, we are having these 3 class of errors. Now let's talk about them one by one very quickly. Absolute error is what? Absolute error is generally the error which gives us the value, which gives us the finite value, that by what margin we fall short or moved a bit ahead from the true value. This means this absolute error will be given by, if AE, we are using AE for absolute error, AE will be given by true value minus measured value. Okay, this is what the absolute error is all about. Okay, absolute error will give you a value. How? When we subtract measured value from the true value, means it is the deviation from the true value. It is deviation of the measured value from the true value. This is what the absolute error is. Now, what is relative error? Okay, relative error is what? Relative error, let's talk about the relative error. Relative error basically do what? It relates the error. It relates absolute error with the true value. Now, relative error is given by, let's mark it as RE, relative error. Relative error is absolute error. It is a ratio basically. It is a ratio of absolute error to the true value. Absolute error to the true value. Okay, and when we multiply this relative error with 100, it becomes what? It becomes percentage error. Okay, it becomes percentage error. Clear? Now let's talk about all these with a example. Let's talk about these errors. I hope you are clear with it. It's not very tough. It's quite easy. Absolute error is true value minus measured value, means deviation of the measured value from the absolute value or true value. And relative error is what? It is a ratio of absolute error to the true value. And when we multiply relative error with 100, we get percentage error. Okay, so these are the 3 errors. Now let's talk about these errors based on the example. Let's quickly take an example which will summarize these. Let's say for an experiment, the true value is 980. Okay, let's say for a particular experiment, true value is 980. Okay, 945. So if we have to find the absolute error, just write down the formula. You have the values. Absolute error, how much will be the absolute error? True value जो भी रही है minus measured value जो हमने measure की है, कितना हो जाएगा? It will be 35. Okay, this is the error, absolute error. Now if we have to find the relative error will be, relative error कैसे निकालेंगे? Relative error is your what? It is absolute error upon true value. Absolute error कितना है? 35. True value कितनी है? 980. इसको आप डिवाइड करिए. How much you will have? Percentage error will be equal to 0.036, because this is what the relative error was. multiplied by 100. So it will be how much? It will be 3.6%, means 3.6% error is there between these two, true value and measure value. So I hope by this particular video you will be quite clear with errors and its type on the basis of qualitative approach and on the basis of quantitative approach. In case if you pop up with any sort of doubt, feel free to leave your doubt in the comment section so that we can rectify it. Okay, thank you for watching the lecture. Keep learning physics. Thank you so much. Have a great time.